First, let me tell you a bit more about myself, right? So, yeah, I'm VP Engineering at Twingate. I've previously co-founded and was CTO of Monday.com, as well as helped a lot of startups that are now companies that you might know. I'm from California, San Mateo. First time in Boston, like it so far. Yeah, and let me tell you a bit about Twingate, right? So it's not a pitch about Twingate, just some setting context why reliability matters so much to us. So basically, Twingate provides remote access to its customers, basically replacing VPNs, allowing you to set up and access remote resources in private networks that you have. Which means we're basically the network layer for our customers. So we have to be up, right? If we're down, you don't have network, you can't get work done, which is bad. So we started late 2019. We immediately saw good traction, lots of nice logos, as you can see. We passed 1 million ARR in less than a year, and then the sky came falling down, right? So we had a couple of major incidents at the end of 2021. And whenever such an incident happens, executives have to go on an apology tour, engineering have to work on post-mortems and stop whatever they're doing to do fixes. And AEs and sales and support, they have to take all the heat from customers. And it's really not nice. It's defocusing all the teams from their usual work and demoralizing. And since we had these, two major incidents, morale was very low. And we needed to win back the trust of our company internally. First, AEs, support, they were really in bad morale. And our customers that were threatening to leave, right? So you think about our champions, they chose Twingate and they made a bet on a startup instead of going with a more mature brand. And now they're thinking, why did I do that mistake? And we need to win their trust back, right? Just to put the numbers in context, if you're aiming for 4 nines, that's only 52 minutes, less than an hour a year, less than 15 minutes a quarter. So if you think about it, you have an incident, just gathering all the people in the room, trying to find out what happened, that's more than 10 minutes, boom, your time is up, right? So you need to be very methodical and add automations to reach those times. Very challenging. Okay, so first let's talk about where we were, what's our baseline, right? So you'd think, these guys, they had these incidents, they're probably using outdated processes, maybe they need to upgrade their technology. And I think at least we're not, right? So if you look at our stack, we're using Kubernetes on Google Cloud, Terraform to automate everything. Developers don't have access to permissions to do stuff on the cloud environment. Everything has to be automated. We're using ELK to send all the logs there and as an APM to monitor performance. Prometheus Grafana for metrics, for custom metrics and alerts. Circle CI for CI. On the back end, we're using Python, Django app, Monolith at the time. Admin console is JavaScript, Next.js. We use GraphQL for all our APIs. And client apps, we have native clients, so they're written in whatever the native language for that platform is. We have a C library that, where we implement the common logic for everyone. So again, we automate everything. Frequent deploys, our goal is to always keep the develop branch as close to master as possible, because then if something breaks, you can quickly roll back and you know what broke. We use all the code quality tools, so PyLint, Bandit, all the code scanning tools, full test coverage, like 98-ish% coverage, and we have integration tests, and we have smoke tests that test the actual environment after we deploy and hourly to make sure nothing breaks. Monitoring, like I said, we already had monitoring, APM, logs, custom metrics, alerts, integration to Ops Genie. We have an Ops channel in Slack. Whenever something happens, post there, everyone gets a notification and they can go look and help see what happens. And we had an on-call rotation, runbooks. If you don't know what a runbook is, whenever we have an alert, it has a link. It goes to this Notion document with all the alerts, and it takes you to that specific alert, what you should check, who you should wake up if something really bad happened. So good practices, I think, already at the top percentile, but it's not good enough because reliability requires more, right? So action plan. So first, what we did is we decided we need to prioritize reliability. For us, reliability is a feature, and we need to start treating it as a feature. So it needs engineering time, just like any other feature. We set up a reliability task force with the engineering leads in the company and identified the projects we want to execute and the priorities. And we defined it as a company priority. So we said to the company for Q1, we're not going to do and deliver any new product features. We're focusing just on reliability. Yeah. And in order to win back the trust internally and externally, you have to communicate, right? So we have weekly all hands, and we shared all the projects every week, all the projects. Why are we doing them? What do we expect to achieve with each project? And what's the status? So this is an actual slide from one of our all hands where you can see ownership, which engineers own which project, and what's the status on each of them. And we also kept it transparent with customers. So we communicated the same stuff that we communicated internally, we communicated to customers. So they were getting the same slide. And for the important customers or customers that wanted it, we also set up weekly status calls with their AEs or with our management to go over the projects and tell them what we're doing and how we're doing on our goal. Okay, so what did we actually do? So before we go to the actual projects, it's important to say what's the arc goal of reliability, right? So with every project, our goal is to reduce the blast radius, right? Because stuff is going to happen, errors are going to happen, whether it's your fault, whether it's the cloud provider that messes something up. And you need to aim for when that something happens, the blast radius is minimal, right? You don't want the entire system to be down, maybe just part of it, or maybe not the critical stuff. So that's the goal behind all these projects. So the first project was, a simple aha moment. We had this Django monolith that was handling all of our requests. Some requests are critical, some are not. Some requests high latency, some low latency. And we figured that instead of having one deployment on Kubernetes and scaling that according to traffic, we'd be better off just taking the same code, deploying it as 8 different deployments in Kubernetes, and splitting the traffic on the load balancer, right? So we went over the APM, looked at all of our transactions, and categorized them based on criticality, critical or not, and based on latency. And then we split our service into, I think, 8, 9 different services, different deployments. So still, same code, every deployment can serve all the requests, but we separate the traffic on the load balancer. So this way, something breaks in one of the subcategories, it doesn't affect all of them, right? So I don't know, authorization requests are broken because our authorization database is down. It doesn't affect our public API or our admin or whatnot. So high value, very low effort, like 2 days we were able to split the deployment, set up some rules on the load balancer, very good value. And you can keep using a monolith, don't have to, split your code to microservices, which is a lot of work and adds a lot of, overhead, engineering overhead. So this is a screenshot of our APM, Elastic APM, if you know it. I don't know, every morning, that's the first thing I go to, APM, I monitor all the metrics. If you don't have APM, you should. Yeah, so you can see for every transaction, you can see average latency, throughput, and we just went over, and you can drill down to see exactly the details, but this is what we use to split up, to figure out how to split our services. The next step, we looked at our database. So we were using one database to write and read. Still high availability from Google, so it's like two servers. If one goes down, the other one takes its place, but it's not good enough. So we wanted to do read replicas. So we set up read replicas to all our database. We set up the Django. We did the Django code to read from replica right to primary database. And we had to audit all our flows to make sure you don't read something and then you don't write something and then expect to read it back again because there's some latency. In cases you do have to write something and read after, it needs to be in a transaction. So yeah, we had to audit all those write flows and make sure they're okay with this new setup. And then again, there's the title at the bottom, practice makes perfect. So in DevOps, we have, once something is working, it's not good enough to know that it's working. You have to keep drilling it, keep like monthly or quarterly, checking that it still works. So when you add stuff like that, like replicas, you want to make sure that certain disaster scenarios always work. In this case, replica is down. We want to make sure the system automatically sends traffic to the other replicas. Primary down, we want to make sure that we know to take one of the replicas, promote it to be primary. Right? So you add these scenarios to our ops, I call them ops drill log. And each of these scenarios, we drill at least quarterly. We have a Notion page where every time someone drills, writes everything he did, make sure that it still works, right? Because the system is dynamic, someone can add something that breaks, forget about something, so you want to keep drilling those scenarios, disaster scenarios. The next thing is we said, what if the primary is down? We still want most of our system to work, right? So we did an audit of all our write passes and categorized them critical versus non-critical. Example for a non-critical, when a device logs in, we update the last logged in column, right? So if primary database is down, do we want to not let you log in because we can't update that field? No, right? So we went over all those write paths and those that are not critical, added code that lets them fail without failing the entire transaction. We also introduced read-only mode. So if something is fishy with the database, maybe latency goes up, we see an increase in alerts, the system automatically goes into read-only mode and blocks write. Because we saw that sometimes when something is acting up in the database, just having more writes and failures and retries just increases the issue more. So the system automatically knows when there's a spike in errors, it knows to switch into read-only mode. Read-only mode, so you can't edit stuff in the admin, but everything else still works. Yeah, and it lets the team handle the primary database, figure out the issue without being bombarded with even more traffic. So those three were relatively easy projects. Now we went to the real big one. So because one of the incidents we had was actually Google region being down. They broke the load balancer or whatnot. We wanted to avoid that. So we needed to be in multiple regions, active. So again, we set up 2 more clusters. So now we're in 3 regions across the US. We set up Google Global Load Balancer to point traffic to the nearest cluster. And again, it required clusters to be stateless, right? So we had some code, for example, that used Redis on the cluster, assumed that the data is there. Now when you have multiple clusters, you can't do that. So we had to audit all those transactions, move the data somewhere else, use Redis only for cache. And again, practice makes perfect. This adds 2 more disaster scenarios that we need to drill. How to set up a new cluster from scratch. Because the system is dynamic, like I said, services keep adding up, dependencies keep adding up. You want to make sure that you know how to set up a new cluster from scratch and nothing broke the process that used to work. And you want to be able to know that if something happens to a region, you can kill traffic there, or it gets killed automatically because Google broke, and all the traffic goes to the other clusters, and you want to make sure that those clusters can scale to handle that extra traffic, right? So that's another task that you need to keep testing and making sure that if one cluster goes down, the other clusters can adequately handle that traffic. One of the nice byproduct of this project is that now we can upgrade Kubernetes easily. We just mark a cluster as off, remove traffic from it, and then we can upgrade it, put it back into circulation. We can add traffic. So right now, we have two components, our main server, and we have like relays that route the traffic. So main server is, we have 4 clusters right now across the US, active. And the relay service we run in every Google region. So like 16, 17 clusters, I think. Everything is active, monitored, and we keep practicing those things to make sure it keeps working. Okay, another problem we had, thundering herd. If you don't know what it is, basically we were DDoSing ourselves. Whenever something happened, one service was slow or down, clients kept retrying, it increased the load. So even when we fixed the database or we fixed whatever was happening, the service would go up and immediately fall down again because it couldn't handle the traffic. Right, so we added randomization to the backoff. We don't want all the clients to come to the server at the same time. For this example, we use 25% turns, 25% skew on the timeout. But yeah, whenever you have a service and you're thinking about reliability, you need to think about who calls it, how frequently, and make sure that you don't have a thundering herd like, yeah. So we're using JWT tokens for authentication. Clients would call the server whenever the token expired and they need to renew it. All the tokens were expiring at the same time. So think about it, people come in the morning, open their laptops, all the clients contact the server at the same time, and then they keep doing it every 5 minutes, unless you add randomization. So while we were working on the thundering herd problem, we said, what if the entire server is down? Let's say Twingate is entirely down, all our clusters are down. There's a problem with the load balancers. Why? Because it happened. Google had a problem with the load balancers and nothing was working, even though it's multi-regional and everything. And we want to be able to have our service working, even if server is entirely down. So if you know JWT tokens, they have an expiration. And whenever a token is expired, the client can't use it. So what we did is we extended the protocol to allow, so there's short expiration and extended expiration, right? So short would be the previous expiration, like every 5 minutes. Long would be 1 day. And the services validating the tokens, they know to either use the short or the long expiration, depending on whether the server is up or not. So if Twingate is entirely down, or backend is entirely down, clients that are logged in, of course, new clients can't log in because there's no server, but if you're already logged in and transferring something or accessing a remote network, you should still be able to do that. On the operational side, we needed a better on-call process, right? So like we saw earlier, if you want to do 4 nines, the timelines are very, very, very short. So you want to automate escalation process and have a process for everything that happens because stuff will happen, right? So let's say there's an incident, we have a bot, you write start incident in Slack, automatically there's a channel created, there's a Notion doc for postmortem created where you can start logging the timeline, and people are assigned roles, right? You need someone that just listens on the call and writes the timeline of what happens, what's being done. And you need to bring in someone from support, AE, product to do customer communications if needed. So yeah, so we did that automation. We went over all the runbooks, make sure that all the support people that they're all documented properly. Whenever something happens, there's a real good process of how do you handle that alert and fast, and who do you escalate to and when, and made sure everyone knows the process. And again, like I said before, practice makes perfect. So all the infrastructure stuff, you have to go over it very often because the system changes, stuff may break. So at least every quarter, we have a list of scenarios. At least every quarter, we run all of them and make sure they work and document it. Sometimes stuff break, you need to fix it, so everything is documented. So we know. It's also a SOC 2 thing, so we document it for SOC 2 too. And it's boring and annoying. So manager tip, if something is boring and annoying, developers will want to automate it, and that's better, right? So it makes the DevOps guys automate most of this stuff, write it into scripts. We started with, like for each scenario, a Notion doc with a bunch of manual stuff, and gradually, over time, we saw the engineers automating a lot of it. So aftermath. We saw zero churn after this project, so it took us like a quarter, maybe quarter and a half to get all of these done. Team, or if you're wondering about team size, we had about 3 people in the DevOps team and about, I think we were 15 in engineering total, maybe less. Yeah, so zero churn, which is good. No, we didn't lose any customer. And we actually, customers now see reliability as a value, right? We have a very good track record since then, and the customers like it. Even when comparing ourselves to more mature companies out there. And the system is way more resilient to spikes. So one of the stories I like to tell here, we were working with this YouTube influencer, and of course marketing didn't let us know in engineering that he's going to publish a video. And he published it at like Friday afternoon, and suddenly we saw 20x the traffic, right? Marketing was surprised too, right? So we saw 20x traffic than we usually see. I was on PTO, I was on my way to Fiddme Beach, and I was already thinking, my wife is going to kill me, I'll need to be on the laptop the whole weekend. But no, the system handled it. We handled 20x the sign-ups and traffic that we usually see. It just worked. So peace of mind to engineering. This is the latest graph that for our reliability. I just showed it on our board meeting last week. 8 consecutive quarters that we exceeded our internal benchmark. So for customers, we commit to 3 nines, 99.95. Internally, we commit to 4 nines, and we've been doing that for 8 quarters. Which lets us do other nice things, right? Instead of just focusing on reliability, DevOps team can focus on platform engineering, making shared code that everyone can use. Focus on finer pricing control. We started using spot instances to optimize our workflows and do other cool things instead of dealing with reliability. So, which brings us to what's next. So, reliability task force still meets regularly. We look at when we prioritize projects, we have like requirements from product and support and engineering backlog, tech debt, and we also have reliability, and those projects get like their percentage of the work allocated. So we still have the task force meeting regularly. I think every 3 weeks or so. Look at projects, prioritize them. Reliability is a core tenet in every feature we do. So we added to our technical spec a reliability title to make sure that whenever an engineer works on a feature, he keeps that in mind, that it needs to be reliable, it needs to work in an active architecture. And our next big thing, which is a lot of work, it's very hard, we want to shard our production. So right now we have 1 production environment. Sure, it's 4 clusters, active, all of that. And we want to be able to take that and shard that, right? So we have multiple productions. For engineering, this, again, reduces blast radius. There could be like a problem with one production, or maybe we deploy them not together. So code bug, it hits the lower production, or the like for the free tier earlier. But it's also a sales advantage. So in the future, we'll want to do data locality, maybe set up a Europe specific or a Canada specific, or when we go to FedRAMP and stuff like that, which I hope is not soon, we could do that. Yes, so that's a really hard project. You know, all the ideas are duplicate. I can talk about that for a whole 30 minutes just on its own. Yes, that's it. So questions, I don't think we have time for questions, do we? 5 minutes. Okay, so yes. So I don't think I had to do it, right? So enough with these incidents, right? So I remember one of these incidents, I didn't sleep for like 3 days because we were working with Google support and, you know, people. So engineers were frustrated too, right? You don't want to be on call if you know stuff is going to break, right? So that wasn't a problem. Yes? So there isn't a custom metric that I think was significant. So we already had lots of custom metrics like number of requests and stuff like that. We still use, for auto-scaling, we use the Kubernetes HPA, which uses like CPU and memory, which isn't that good, in my opinion. CPU is not a good metric to scale by. But that's what we have now. We recently started looking into scaling by custom metrics. Yeah. Over there. Top. Yeah.
Sounds wonderful and very expensive. How do you keep your eye on cost as you roll out these new features?
So when we did this project, cost wasn't a problem, right? Because it was a do or die thing for the company, right? So more clusters, okay, let's spend money on more clusters. But like I said, now that we are pretty stable, right? 8 quarters in a row, that's a lot of time. It lets us do more projects that are about cost control, right? So for example, all our background processes, like queue tasks, we move them to spot instances. Yeah, so spot instances was a huge thing. So definitely before every board meeting, I have to report. So so the metric I look at is cost of infra as percentage of revenue. Now it's affected by top line growth too, right? So customers, but it's also affected by optimizations we do on the engineering side. We're not at a stage where we're extremely cost conscious, right? So for example, having multiple production environment, that's going to step up the costs, right? But long term, it's going to reduce them because each environment is going to be smaller compared to one big environment. So yeah, so we look at it at like a monthly, at minimum quarterly, but monthly, but mostly depending on the project, right? If there isn't any project that's actively working to reduce costs, then I know it's not going to change drastically. Yeah. So that's why the drilling part is important, right? So you have to drill quarterly. If it was up to me, then more often, right? But you know, I need more people. You have to drill quarterly, taking down a cluster, taking down the database, taking down Redis, and making sure that the system works. yes, right? So if you, we're not doing like Chaos Monkey that takes it down all the time. There's incidents going all the time, right? It's not that it's quiet all the time and we're not doing anything and once a quarter we take down the database, right? So there's stuff happening all the time. Google helps us, with that. If it's quiet, then Google will help us with weird errors that they won't admit. So there's incidents, small incidents going all the time. You're done. Okay. So one last sentence. So if previously one such a Google networking error would be a major incident because we can't connect to the database, now these are small incidents and we see that the system is working. Yeah. So if you have any more questions, I'm around. Find me. Thank you.